let's talk about app settings for a while. If you're building a run-of-the-mill web API, for example with ASP.NET Core's Minimal API framework, you typically end up with an app settings file. That app settings file contains settings and it is published together with your application. It is one of the things that the framework looks at for your application settings. In case of a function, it's a bit different. There is no app settings file here, but there is a local settings.json file. These values are only used locally, so the file is not deployed together with your function. Yet somehow this kept working. Why is that? Well, the reason this kept working when we published the function app is that the settings we have in here were either automatically defined as an environment variable when we created the function app on the portal, or were set up when we connected dependencies right before publishing. That's how the connection string ended up in our function app over on the portal. But imagine that you have another application setting, say one that defines the maximum amount of itineraries to return. Settings for the function app should be defined as part of the values. So let's name that maximum amount of itineraries to return. Let's put it to 2. And let's save our local settings file. And then let's make sure we use this setting in code. So let me open the getItineraries function. Let me inject an iConfiguration object so I can access this setting. Then let me try and get that value. So I try and parse maximum amount of itineraries to return using the configuration object. If that doesn't work out, I throw an exception. If it does work out, the parsed value will end up in the maximum amount of itineraries to return variable here. And then let's make sure that we effectively use this value. So I'm only going to take the maximum amount of itineraries to return here. All right, let's test this locally just to see if it works. Our function app is up and running. Let's send a request to get the itineraries. And this still works as expected, and only 2 items are returned. Just to be sure, let's change the value. Let's put it to 1. And let's do that again. Let's send the request. And this time only 1 is returned. So far, so good. This definitely works. Now let's publish this function again. So let's open Publish Profile. And let's click Publish here. In the meantime, publication has succeeded. Let's send the request we previously sent again. And you'll notice that this will just keep on running and running and running until it eventually fails. The reason for that is that the application setting is not available on Azure. Let's have a look at the environment variables. And if you look at the app settings, there is no maximum amount of items to return here. And as we know, the local settings file isn't published together with the function. So how do we solve this then? Well, we could of course just now manually add the setting here, but there's another way of doing that I want to show you. We're back in Visual Studio. If we click these 3 dots next to hosting here, we have an option to manage Azure App Service settings. And what we see here is that some settings have local and remote values. Some settings only have remote values. And others only have local settings but no remote values, like our maximum amount of itineraries to return. From here you can manage that. Let's say I'm going to put the remote value to 2, just so we have a difference between local and remote. So let's do that. Let's click OK. And I've just refreshed the app settings over on the portal. And here's our maximum amount of itineraries to return with value 2. So that's how you can manage app settings directly from Visual Studio. All right, let's give this another try. Let's first restart the app so our new settings are taken into account. And let's navigate to API/itineraries. And there we go. We immediately get back our 2 itineraries. As an alternative, as you could probably guess, you can also use the CLI to manage these settings. The command you're looking for is az function app config, app settings, and set to set a setting. Up next, we will improve the security between our function app and our SQL database by using a managed identity. In the Getting Started course, I detailed why managed identities are the safer option to secure access between Azure resources. The main reason for that being that you no longer have to manage secrets yourself. These are automatically managed and updated by Entra ID. We have a use case where that can be beneficial. We are accessing our Azure SQL database from the function app using SQL Server authentication. Let's switch that to a managed identity. As you remember, to create connections between Azure services, we can use the service connector. So, at the level of the function app resource, let's navigate to the service connector blade. There's already a connection here to our SQL database, which ended up here because we published a function app that connects to a SQL Server database. But we want to create a new one that uses a managed identity. So let me click Create here. And the service type we want to select is a SQL database. This will feel very familiar if you followed the Getting Started course. We can give it a name, say app-dev scon for service connection, dev WE travel inspiration itineraries. I want to use my Visual Studio subscription and the SQL Server that contains my database. I also select the database and the client type is .NET Client. On the authentication blade, I choose to use a system-assigned managed identity. On the networking blade, I choose to configure firewall rules to enable access to the target service. And that's it already. I click Review and Create. These are the 2 commands that will be executed. As you remember, you can just copy-paste them and execute them from the Azure CLI locally, or we can wait a minute. And then the Create on Cloud Shell button here becomes blue, and we can execute these commands in the Cloud Shell on the portal. So let's do that. All right, that did it. Let's close this, and let's have a look at the identity blade here. We see that the system-assigned managed identity was enabled for this function app. That is one of the consequences of the script you just executed. Let's have a look at the environment variables. And we find a new setting here, Azure SQL connection string, which contains a connection string with authentication set to Active Directory managed identity. This is the connection string that we need to use a managed identity to connect to the SQL Server database from this function app. Now, of course, we do need to change one thing. Our application doesn't expect the connection string to be in setting Azure SQL connection string. Our application expects the connection string to be in Travel Inspiration DB connection. This is where I previously added my username and password. Let's get rid of that. Let me paste in the one with Active Directory Managed Identity Authentication. Let's click Apply. Let's click Apply as well. The application will restart, so the new connection string will be used. All right. And let's give that a try. So, API itineraries. And there we go. Works as expected, this time using a managed identity. So, there's no need anymore for that SQL Server authentication. Then again, we are still using it locally, right? If we have a look at the code base, we see that in our local settings, I am still using SQL authentication. We know how to fix that, because we fixed this in the Getting Started course as well. We can get rid of this local connection string by working with the default Azure credential. It's just a few lines of code, and it's a simple copy-paste from what we did in the Getting Started course. So let's quickly do that as well. So, In the Getting Started course, in the API project, we switched to using default Azure credential. We did that in the Service Collection Extensions class. We first knew up a default Azure credential, used that credential to get a token to access Azure SQL, then set up the SQL connection with that access token, and then pass through that SQL connection when we set up the DB context. Let's simply copy this over to our function app project. It's in the program class where we set up the DB context. So I can get rid of that. And the only thing I'll need to change here is the way I access my configuration. So what this code does is, when running locally, it will use the account I'm using to authenticate to Azure services as configured in my Visual Studio. In my case, that is my Azure account. And when this code is deployed on Azure, the default Azure credential will, by default, use the managed identity to get the access token to access the database. So that's how you can nicely develop locally and make sure that your code can be deployed without having to be changed to run on Azure using the managed credential. The one thing we do need to make sure of now is that we get rid of the authentication part in the connection strings. That's because it's now this access token that actually replaces that authentication part. Let's do that on the portal first. So I'll open the environment variables blade onto connection strings. And let's edit this. I'll simply get rid of the authentication part here. And I'm copying this because I want to use the exact same connection string locally. Let's click apply. Apply as well and confirm. Locally, let's change the setting here as well. So my travel inspiration DB connection string will become the exact same one I'm using over on the portal. Let's save this and let's publish this. Right, publication has succeeded. Let's give this a try locally first. All right. Let's send a request to get the itineraries. And there we go. That worked as expected. Now let's give this a try online. And with that, we got rid of that SQL Server authentication connection string. But what about securing the outer layer? In other words, allowing or disallowing requests to the function app endpoint. Let's learn about that next.